வணக்கம் நண்பர்களே, மீண்டும் ஒரு வீடியோவில் சந்திப்பதில் மகிழ்ச்சி. ஸோ இன்னைக்கு கிளாஸில் லாஸ்ட் கிளாஸ் கண்டினியூஷன் தான் நம்ம பார்க்க போகிறோம் ஃப்ரம் சாலிட் ஸ்டேட் ஃபிசிக்ஸ். ஸோ நிறைய டாபிக்ஸ் we have to covered ஃப்ரம் லாஸ்ட் 2 to 3 weeks. ஸோ பார்க்காத நண்பர்கள் சேனல் பிளேலிஸ்ட்டில் இருக்குது, போய் பார்த்துங்க. ஸோ இன்னைக்கு கிளாஸில் we discuss about the specific heat theories. So first one, there should be 2 theories are there. Then first one, the Einstein theory of specific heat. So what is the assumption for the Einstein specific heat? A solid contain n atoms, then each atoms has 3-dimensional harmonic oscillator. So in that all atoms oscillate with same frequency, which is called as monochromatic approximation. So what is the energy level for Einstein theory of specific heat? Quantized, then En is equal to n plus 1 by 2 hv. These are all the assumption we have to remember while studying the Einstein theory of specific heat. So these are all the some of the most important equation we have to simplify and we have to present here. Then average energy per oscillator, that should be a most important. Then hv by kt minus 1. This is most important for doing the problem in the next classes. Okay, then total internal energy, then U is equal to then 3 NeV, which is equal to where n is the number of their atom, then hv by e power hv by kt minus 1. Similarly, after we have to find out the specific heat at constant volume, then Cv is equal to dou u by dou t at constant pressure V. Then we have to apply and substitute, then we have to finally get this one. So final equation is most important. Sometimes they should be asked in direct way in the question paper. So from the previous slide, in that specific heat, then Cv is equal to, here we have to take define the Einstein temperature, we have to take, then theta E is equal to hv by k, where all the hv by k present, in that place we have to replace theta E, and finally we have to get then Cv is equal to respect relation. So the last equation, which is called as the Einstein theory of specific heat. After that, there should be 2 cases, most important cases. One is low temperature and high temperature. So most of the question may be asked like that. So there should be 2 cases. One is high temperature, then temperature is greater than Debye energy, that should be theta E, which is equal to then Cv is equal to 3nk. So abadi pochina, that is called Dulong-Petit law, most important. At low temperature, T is lesser than theta E, then specific heat of volume is directly proportional to then e power theta E by T, which is called as exponentially decreases. So graph pathirundinga we have to easily understand that. Most important, what are all the cases you have to remember? High temperature la enna nadakudhu, low temperature la enna nadakudhu. Most of the question may be comes in that part only. So what are all the limitation for Einstein theory of specific heat? Most important first one, then is Einstein theory of specific heat fails at low temperature. Okay, it does not fit, then Cv is directly proportional to T cube behavior. So in that Einstein theory, then assume all atom oscillate with same frequency. So these are all the limitation. Okay, so next move on to the then Debye theory of specific heat. So some of the assumption we have to know about that. Then vibration of atoms are collectively phonons, so then frequency are not equal. Then previous Einstein theory of cases la only all the atom oscillated with same frequency, but in the Debye theory the frequency are not equal, it should be a different. So the ranges from 0 to 2 maximum cutoff frequency. So similar way we have to present here then total energy and then specific heat. Then we have to anga vandu define Einstein temperature, inga vandu Debye temperature we have to define that. Then theta D is equal to hv d by k, that is called as Debye temperature. After we have to substitute, then we have to get the final equation Cv. Okay, so similarly same thing we have to follow for what we have to done in the Einstein theory of specific heat. So behavior at high temperature, T is equal to then Cv, it goes to 3nk. At low temperature, Cv is directly proportional to T cube. It matches experimental result. Some of the advantage, then Debye temperature, Debye theory of specific heat explain both high and low temperature behaviors. So in that Einstein Debye fit experimental data well. So I hope you have to understand for short notes for specific theory for Einstein and Debye theory. Don't forget to like this video and share this video to your friends. We meet in the next video. Thank you.